In this lesson, we're going to look at how we can solve for angles in right-angled triangles. So first of all, recall that the interior angles of a triangle add up to 180 degrees. So if we have a right triangle, we know that one angle is 90 degrees. And if we have one other angle that we know, then we can solve for that by subtracting the 90 degree and the other angle from 180. So right now we need to solve for angle K. So the number of degrees for angle K is equal to 180 degrees, so the total of all three. Subtract 90 degrees for the right angle and 23 degrees for angle P. And if we subtract that, what we're left with is 67 degrees. So angle K is equal to 67 degrees. In this next triangle, we have a right angle, which again is 90 degrees, and Z is 62. So K is equal to 180 degrees minus 90 degrees minus 62 degrees. So K in this triangle is equal to 28 degrees. So anytime we know two angles in a triangle, we can solve for the third by subtracting the two angles from 180. Now, if we do not know either of the two angles other than the right angle, then what we can use is the primary trig ratios that we just learned. So first we're going to look for the angle that we want. And then we're going to identify and label the hypotenuse, opposite, and adjacent, which we learned how to do in previous lessons. And then based on which of these sides we have, we are going to create a primary trig ratio. So if we only have two sides, then we're going to be limited by those two sides as to what our primary trig ratio is going to be. Then we're going to calculate the primary trig ratio into a decimal, and then we're going to do what is called the inverse trig operation. So if we have sine of theta that we're looking for, so theta, recall, is what we're using for the unknown angle, kind of like we use x to represent an unknown side. So this is theta, it's pronounced theta. So it's just the symbol that we use to represent that unknown angle. And then we're going to round our answer to the nearest degree. So let's look at a couple of examples over here. So over here is the angle that I'm looking for. So I'm shading that in so that I can identify my hypotenuse, opposite, and adjacent side. So remember, hypotenuse is always across from our right angle, so that's the 7. And then across from the angle that I'm talking about, so theta over here, is my opposite. And the other side is adjacent, but I'm not going to write that down because I don't actually know what that side length is. So I'm not going to bother. So what I'm looking for is which trig ratio uses O and H. So you may recall that we have SOHCAHTOA, and that can help us find out or remember the three trig ratios. So O and H is sine. So the sine of theta is equal to the opposite divided by the hypotenuse. So for angle theta, the opposite divided by the hypotenuse. So that is equal to 4 divided by 7. So in your calculator, you can divide 4 by 7 and then leave the answer up. And this is going to depend on your calculator, whether you can leave that answer in and just hit the inverse sign. So that's going to be the case for certain calculators. So I'll show you what that looks like, but that's not how this calculator works. So 4 divided by 7 equals, and then when you get your answer there on some calculators, if you then find your inverse sign button and hit that, that will work. On other calculators, what we do is you can actually take that inverse sign button and then in brackets type in the 4 divided by 7, and that will calculate the angle for you. And we're going to round to the nearest whole number, so 34.8 rounds to 35 degrees. So over here, so this is what sine theta is going to equal. I want to solve for just the angle, so I need to move that sine function over. So I do that by what is called the inverse sine. So I'm taking the inverse sine of 4 divided by 7. So I can write a decimal here if I want to, or I can keep it as this. So once again, in your calculator, you may need to hit a second function. You have to find where that inverse sine is, and then bracket 4 divided by 7 and hit equals, or you might need to do 4 divided by 7 and then hit the inverse sine function after. So this can be a good question where you can figure out what to do, because you know that your answer here should be 35 degrees. So it's going to be 34.8 and then some more decimals, and that will tell you that you're doing that correctly in your calculator. Another thing you want to check on is the degree mode. Is DEG for degrees or D? And if that's not the case, you may want to Google how to change your mode on your display to be in degrees and not radians or gradients. Okay, let's do one more example. So we have our angle theta here that we want to solve for. And our hypotenuse is over here. And across from theta is our opposite. I don't know that side. What I do know is the third side, which is adjacent. So if I look back over here, adjacent and hypotenuse is cosine. So I'm going to write the cosine ratio. So cosine of theta is equal to the adjacent divided by the hypotenuse, which is 21 divided by 24. Now to solve for theta, I need to move over my cosine function. The opposite of cosine is inverse cosine, and then in brackets 21 divided by 24. So I need inverse cosine of 21 divided by 24. So here, inverse cosine of 21 divided by 24. And that is equal to 28.955, so that is closer to 29 degrees. So as I round to a whole number, theta here is equal to 29 degrees.